ChatGPT runs on transformers. So do most famous language models. But what if the architecture behind the AI boom is also becoming one of its biggest bottlenecks? Here's the misconception. Large language model does not mean large transformer model. Transformers dominate today, but they are only one way to process language. Transformers won for good reasons. During training, they can process many tokens in parallel. Attention also lets every word directly inspect every other word for useful context. The trouble appears when context grows. With full attention, twice as many tokens can mean roughly 4 times as many token comparisons and a growing memory cache during generation. State space models take a different route. Instead of repeatedly comparing all past tokens, they compress what matters into a hidden state that evolves as new information arrives. Mamba made this idea compelling for language by adding selection. It learns what to remember, what to update, and what to discard, without using a conventional attention layer. The attraction is linear scaling and efficient recurrent inference. The trade-off is compression. A fixed state may not preserve every exact detail as naturally as explicit attention can. Think of it like a summary. Mamba is great at the gist, but in a needle-in-a-haystack test, finding one compressed state can sometimes overwrite that crucial detail. Transformers, by contrast, keep the entire haystack live. They can look back at the exact cost of that massive, growing memory footprint we saw earlier. RWKV revives another old idea: recurrence. It can train in parallel like a transformer, then run token by token like an RNN using a compact, fixed-size state. XLSTM asks whether the pre-transformer champion deserves a comeback. It upgrades LSTM gates and memory structures, including a parallelizable matrix memory. Other contenders include Hyena's long convolutions and RetNet's retention mechanism. Both seek long-range text without requiring every token to perform full attention against every other token. Mixture of experts is different. It usually does not replace the transformer backbone. A router simply sends each token to a few specialist networks instead of activating the entire model. But linear complexity does not automatically mean lower power or faster models. Real efficiency depends on hardware, optimized kernels. It's not just the math. Real-world speed depends on the silicon. A model might be efficient on paper, but if it doesn't move data through GPU memory effectively, it stays slow. Transformers still have a massive advantage: mature software, optimized chips, proven scaling, training datasets, and a global ecosystem that already knows how to build and deploy them. So the next winner may not completely replace attention. The likelier future is hybrid matters: efficient recurrence or state space everywhere else, plus sparse experts. Remember, LLM does not mean transformer, and architectures not yet invented are competing for what comes next. Which one would you bet on?